Right? I have a cylindrical can such that the sum of its height and the circumference of its base is 45 pi centimeters. And I have to find the radius of the base that will maximize the volume. All right? So first step, I would draw it. All right? So let's draw it. I have a cylindrical can. That's the radius, and that's the height. And I have to do is I have to maximize the volume. That's a mathematical formula for volume. The volume of a cylinder is pi r squared h. Can I differentiate that? No, it's in two variables. So I must be given another piece of information that allows me to write one variable in terms of the other. And what am I told? The height and the circumference of its base. The height and the circumference of the base has to work out to be 45 pi. Do you understand that? What will that allow me to get, h or r? Well, h is equal to 45 pi minus 2 pi r. 45 pi is what? Constant. So I can differentiate it. So that's h in terms of r. Is that right? So therefore, 4, I can put the volume is equal to pi r squared h. So the volume is pi r squared by h. 45 pi minus 2 pi r. To multiply it out, it's 45 pi squared r squared minus 2 pi squared r cubed. That be correct? In multiplying it out. Now what would I be able to do when I've got the back switch? I can get dVd or 45 pi squared. What's that? That's a constant. It's like 45 minus. Yeah? So it is. So that's 90 pi squared r minus 3, 6 pi squared r squared. Differentiate. And then I know what? I know that at the stationary points, I know the VDR must be 0. So that means 90 pi squared r minus 6 pi squared r squared is 0. How will I solve that? Factorize it. And what's common? Will 6 go into 90? Many times. So 6 pi squared r is common. Yeah? Take it out of here. 15 minus take it out of here. R is 0. So 6 pi squared r is 0. Or 15 minus r is 0. R squared is equal to 0. R is 0. Or here r is 15. So I get two radii, two possibilities, 0 or 15. Now if the radius is 0, what will that give me? The minimum value. And if the radius is 15, and I have to prove that. So to prove that, I must get d2v dr to be squared. So differentiate that. It will become 90 pi squared minus 2 sixths, 12 pi squared r. At r equal to 15, that means d2v dr squared will be 90 pi squared minus 1215. If it's 150 and 30 more, 180 pi squared, which is minus 90 pi to the squared. So I can say it's less than 0. So at r equal to 15, what do I have? A max. Any questions? Now, when r is 15, would you be able to find out the height now for me that corresponds to that? Yes? So if you were asked, you could be asked to find what is this max volume? And H is equal to 45 pi minus 2 pi r, which is 45 pi minus 30 pi, which is 15 pi. So the volume then is pi r squared h, which is pi by the radius, 15 to be squared by 15 pi, and that'll give me the answer of what the actual max volume is. Now, what do you have to be good at? You have to be good at knowing that the 45 pi squared is what? A constant. 45 pi squared is someplace in and around 450. So that's like having 450 r squared. So to differentiate is easy. It is treated as a constant. What do you think of that one? All right.